Let's see how we can do distance calculations with the Ultralytics YOLO 11 model. So in this video here, we're going to jump into code, see how we can go through a few videos and also estimate the distance in pixels between different objects that we're detecting. Distance calculations, relation between objects and all that is a very big component in computer vision, especially when we're talking about both 3D computer vision, 2D computer vision. You can use the bounding boxes to project them out, get rough estimates of how far the objects away from each other, how far away from the camera, and also just the relations in between. It's not perfect if you do it in 2D space, but you can do some rough distance estimates. You can come up with references and all that. We're going to go through that in this video. So let's just jump straight into our Ultralytics documentation. If you go inside the solutions tab, on the right side or left side here, we have our distance calculation. We already have a video with the YOLO V8 model. It's a bit old. We have made some updates and also just more clarification on how is it actually working. So here we can see an example where with this solution that we're going to spin up, we can just choose the objects that we want to calculate the distance between. This is very useful. Let's say that you have like a traffic control camera sitting up monitoring traffic. You want to see how fast are objects going, how far are cars from each other and all that. And based on the camera's position, some relations and all that, you can make way better estimates of the depth. So it's pretty much just the same as the human eyes work. You can do a depth estimation, especially if you have two cameras. If you only have one eye, it's way harder to actually determine the depth or do some reasoning about the depth as well. So I've just opened up my code editor here. We're going to have a custom model where we actually want to calculate the distance in pixels between these objects that we have. One thing we have to make sure of is that when we're just working in pixel space, it's very hard to get an accurate distance. Right now we can calculate that there is an amount, the distance between these objects are a certain amount of pixels. Let's just say 100 pixels. It doesn't really map to centimeter, meters, or whatever units that we want to use because this is not real world measurements, but we're doing the measurements in our frame pretty much. But could be that we have fixed objects, could be based on the size of the object as well, but also basically how far are they away. Here we have a static camera. I'm just going to play the video. We have this conveyor belt running with different packages. We have a static camera at a certain distance away from it. Then we can actually use that information to do a pixel to millimeter or a pixel to centimeter mapping, and this is usually how you would do it. You can take some measurements in the real world as well, so we know that okay, this part of the conveyor belt is further away from the camera than the right side here, so we might want to have a scaling based on where are we actually detecting the objects. We know that this object here is closer to the camera. It will appear bigger. It's closer. Here, it should be the same size, but they appear smaller because they're further away. So we need to take that into account as well. Most often, you can get away with a linear mapping if you get some measurements here, 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 and here. You can pretty much just have a linear prediction of how do we actually want to scale this pixel to centimeter mapping. So with this script here that we're going to set up, I'm just going to create a new file. Let's just call it distance.py. We go back into the documentation. We just grab this code snippet. This is everything that we have to do. Copy it. There we go. Here we can also see all the different configurations. So this is just the arguments to our actual model. We specify the model. We can have the line width, show confidence, all these different arguments. So the most important is just let's grab this logistic box video. We need to copy the relative path. You can go and test everything out yourself. Like it's so easy to set up. Grab the examples from the documentation. Have most of it available under the video on GitHub and so on. We're just going to output distance output. We have our YOLO in model. We're going to use a custom trained model for this example. So you can use YOLO in model if you just want to have the Coco classes. Let's say that you want to detect cars. You can get an array with that. But here for our boxes, we need our own custom trained model. You could also use like a YOLO E or YOLO world model where you just prompted what objects you want to detect. We want to show the results and we just from Ultralytics Solutions, we have this distance calculation directly out of the box, which is going to take care of what objects are you choosing with the mouse, calculating the pixel distance, and then you can take those results and pretty much just do whatever you want with that in your own applications and projects. So here we're going to print the results. This is what you can access due to pixel to centimeter mapping. So it's basically just a scaling value based on the references you find, and then you scale it with your linear mapping in most computer vision cases. Then you can actually get relatively close or good estimates of how far objects away from both each other, but also away from the camera itself. This is all we need. Let's try to run it. Distance.py. It's gonna pop up. Let's just try to do this box and this box. Here we can see we have the pixel distance between these two boxes. We're running object tracking as well. Right now it just takes the center of the two bounding boxes and calculates the distance. If we right click, we're actually just going to clear the result. And 1 second, I'm just going to take a new one. So let's take this box and this box. Now we're calculating the distance. You can choose specific points. You can take the bottom of the bounding boxes. You can fit them better or whatever, but we're printing all the information as well. So again, just make sure these distances are in pixels. So it's just the Euclidean distance between the 2 points that we have, which is the centers of our bounding boxes. So we're just printing our pixel distance. So on our results object, we just grab our print results pixel distance, and then you will actually go in and scale this with your pixel to millimeter or centimeter mapping function, and that's all you have to do pretty much. Let's run it again and just see an example. Let's grab this package and this package. There we go. We have 400, 500 pixels, 400. So we can see the further it's getting away from the camera, the smaller the act like distance will be, even though the real world distance would be the same, because like they're not moving on a conveyor belt, they're just moving further away from the camera, and the further away they are, you can see the smaller the bounding boxes are. So that's why we need to come up with this mapping based on some references that we set in our image. This is very important to take into account, but it's relatively easy to do, and it makes a huge difference. Definitely go and check it out. This is all you have to do. You can also do it with cars. You can do traffic analysis, all different types of computer vision applications and use cases out there. This is what's taking you to like a next level of a computer vision engineer. How can we actually apply these business use cases to our object detection results? So one thing is just doing the object detections, training the model and so on, but how do we apply the logic, the business use cases, and actually like go into a deeper level with the actual use cases. Hope you learned a ton this video here. Definitely go in and check it out and test it out. It's only a few lines of code, and you can try to come up with this pixel to millimeter mapping yourself. Hope you learned a ton. Hope to see you guys in one of the upcoming videos. Until then, happy learning.